Look at the Mediterranean, the beaches, the cruise ships. Now watch it disappear. 5.5 million years ago, this was a bone-dry desert 3 kilometers down, where you could have walked from Africa to Europe. So how does a whole sea just vanish? And how does it come roaring back as the largest flood the planet has ever seen? I spent days digging through the latest research, all the way down to the scars those ancient floods carved into the seafloor. And what it all points to is simple. Right now, it's slowly happening again. The seafloor here is stacked in layers like the pages of a book, and every layer is a slice of time. Most of the book is plain mud, the stuff that settles out of any living sea. But near the middle, the pages turn white. They turn to salt. That salt is the first clue. In 1970, a drilling ship called the Glomar Challenger lowered a pipe into this sea floor and pulled up a core of rock. The scientists expected mud. What came up was salt, a thick band of it, hundreds of meters down, sitting under one of the deepest seas on Earth. And that should not have been possible. Salt like this forms one way only. You take seawater, you leave it in the sun, and you let it dry out until the water is gone and the salt is left behind, the way a puddle of seawater leaves a white crust on a hot rock. That works for a shallow pool, but this salt sat at the bottom of an abyss. To dry out water, 2, 3, 4 kilometers deep, you don't dry a puddle. You dry a whole sea. The entire Mediterranean. And in 1970, nobody wanted to say that out loud. 2 men said it anyway. The expedition that pulled up that salt was led by 2 geologists, an American, William Ryan, and the Chinese-born scientist Kenneth Xu. Inside the cores, they found gypsum and rock salt, minerals left behind when seawater evaporates. The evidence pointed in one direction. The whole Mediterranean had dried out. Not once, but over and over. They published it, and much of their field thought they had lost their minds. The idea was too big and too strange. Seas the size of continents do not just disappear. Some argued the salt had formed in shallow lagoons, not a dried-out abyss. The debate ran on for years. What slowly settled it was the salt itself, the same layers telling the same story, turning up in core after core from all around the basin. Xu was so sure that he later wrote a book about it and called it simply, "The Mediterranean was a desert." It took the rest of the world a long time to agree. So how do you empty a sea this big? And how could we ever know it happened? Keep that salt in mind. We'll come back to how thick it gets. First, we leave the basin and look at the whole region from above. Africa is moving. Slowly, about as fast as your fingernails grow, the African plate is pushing north into Europe, and it has been for tens of millions of years. The Mediterranean sits in the gap between them like a puddle trapped between 2 doors that are slowly swinging shut. About 7 million years ago, those doors were nearly closed. The Mediterranean was joined to the Atlantic Ocean by 2 thin straits, one through what is now southern Spain, one through Morocco, and the plates were squeezing both of them narrower every century. That mattered because the Mediterranean has a quiet problem. It loses more water to the sky than its rivers and rain put back. Under all that sun, it dries out faster than it fills. The only thing keeping it topped up was the Atlantic pouring in through those straits. Most people picture a sea dying slowly, drying out over millions of years. The opposite is true. Cut off the Atlantic, and the Mediterranean doesn't fade. It runs away from you. The sun kept pulling water from the surface, but the rivers could not replace it fast enough. Slowly, the sea level fell like a bathtub, draining with the plug pulled and the tap turned off. By about 5.97 million years ago, the doors had closed. The tap was off, and the bath began to empty. As the water shrinks, the minerals in it start dropping out in order the same way they would in any drying pool, just on a giant scale. First comes gypsum, crusting the edges of the basin in pale bands. Then the basin is shrinking fast and turns into a salty sea under a brutal sun. The animals that had lived here for millions of years are running out of water. Most of them don't make it. The Mediterranean loses almost everything that swam in it. It was a die-off, and it was nearly total. So how much of the sea was gone, and how quickly? For a long time that was a guess. Then, in 2024, a team found a way to read it straight out of the salt. Different stages of drying leave a different chemical mark, and the salt had recorded the whole sequence. What they found is hard to take in. In the eastern Mediterranean, the surface dropped by somewhere between 1.7 and 2.1 kilometers. The basin lost as much as 70 to 80% of its water, and the worst of that collapse happened in under 10,000 years. 10,000 years sounds long until you remember we're emptying a sea. For something that size, that's almost no time at all. And now, this is the bottom. In the deepest spots, the floor of this dead sea sat 3 to 5 kilometers below where the waves used to be. Stack 6 of the tallest towers ever built on top of each other, and you'd still be looking up at where the surface should be. Down here, the air pushes harder, about half again as hard as it does at the beach, so it's hotter. The pressure is crushing and the salt goes down and down. In places, the salt is 3 kilometers thick on its own. You could bury the tallest building on Earth in it 3 times over and never hit the bottom. The empty basin did one more thing. With the Western Mediterranean drained, Africa and Europe were no longer split by water. They were joined by land, a bridge of baked, salty desert. We can't film the animals that crossed it, but their bones tell us they did. Hippos, camels, antelopes and rodents walked north into Europe across the floor of a sea that wasn't there anymore. The basin didn't just stay a dry desert. After the worst of the drying, it filled again partly with the wrong water. Not from the Atlantic, which was still locked out, from the north and east, from the ancient lakes that would one day become the Black Sea and the Caspian, spilling fresh and half-salty water down into the dead basin. For a while, the Mediterranean became a chain of strange, half-fresh lakes that scientists call the Lago Mare, the Lake Sea. And it filled with life that doesn't belong here at all. Small shells and creatures from the Black Sea region, found today in rocks all around the Mediterranean coast. A 2025 study even showed this northern water started arriving long before the real flood came. The Mediterranean is now a low, salty wetland 3 kilometers down, and the Atlantic is still on the far side of a wall of rock at Gibraltar. But if this basin is bone dry one minute and a chain of strange lakes the next, how does it ever become the deep blue sea you can point to on a map today? Not everyone agrees the basin fully dried out. A 2022 study of that same buried Nile canyon argued the sea might only have dropped about 600 meters, a quarter of the bigger figure. If that's right, the Mediterranean shrank a lot, but it never became a true dust bowl. That disagreement is still live today. What has tipped most scientists back towards the dramatic version is the newer evidence. The chemistry locked inside the salt, and the scars off Sicily we're about to reach. Now, how did all the water flood back in? On one side, an empty basin kilometers deep. On the other, the whole Atlantic Ocean held back by a barrier at Gibraltar. A wall like that doesn't hold forever. Around 5.33 million years ago, the Atlantic found a way through, and what happened next may be the biggest flood in the history of the planet. It didn't start as a wall of water. It started as a trickle leaking over the lowest point of the barrier. But running water cuts rock, and the more rock it cut, the wider the gap grew, and the wider the gap, the more water came through, a loop that fed itself. The trickle became a river. The river became a waterfall over a kilometre tall. The waterfall became something the planet had never seen. At its peak, water poured through Gibraltar at 100 million cubic metres every second, falling more than a kilometre downhill into the empty basin. Take Lake Erie, one of the Great Lakes. At that rate, you could drain the entire lake into this basin in about 80 minutes, and then do it again and again for months. The surface of the Mediterranean rose by as much as 10 metres a day. And it isn't creeping towards you. Where the flood is moving, it's moving at about 40 metres a second, 90 miles an hour. Motorway speed across a Dead Sea floor. 90% of the sea came back in somewhere between a few months and 2 years. Then came the discovery that settled most of the argument. The water filled the western basin first, then it hit a ridge between Sicily and Africa, and once the west was full enough, it spilled over the top in a second flood, eastward into the still empty eastern basin. In 2025, a survey off southeastern Sicily found the scars. More than 300 ridges carved into the rock, all pointing the way the water would have run, leading into a channel 20 kilometres wide. The land kept the receipt. This wasn't the tide coming back in. This was a whole sea pouring back through one gap in a single roaring rush. And the land bridge we crossed earlier? Gone. The sea disappeared. The sea came back. That sounds like the end of the story. But it isn't. The newest research published this year found something nobody expected. Even after the Atlantic refilled the basin in those few violent years, the eastern Mediterranean was still poisoned. All that leftover salt didn't just wash away. The water was back, but it was far too salty for normal sea life, and it stayed that way, flushing out slowly through the new Strait of Gibraltar for another 26,000 years. The flood was the easy part. The recovery took 200 times longer than the disaster. The Dead Sea changed the rest of the planet too. An enormous amount of salt was locked away. Nearly 6% of all the salt dissolved in Earth's oceans. And that changed more than the sea. It altered ocean chemistry, cooled the global climate slightly, and helped reshape life across the continents. One sea drying up in one corner of the world reached the entire planet. For millions of years, this was nature's story. In the last 100 years, it almost became ours. In the 1920s, a German architect named Hermann Sergel looked at the Mediterranean and saw a problem he thought he could fix. Europe was crowded and short of power. So he proposed something staggering. Dam the Strait of Gibraltar. A wall of concrete more than 30 kilometres long, sealing the sea off from the Atlantic. The same gateway that had drained and refilled it 5 million years before. With the Atlantic shut out, the Mediterranean would start to evaporate exactly as it had in deep time. Sergel wanted to lower it by up to 200 metres. The retreating water would uncover huge new stretches of land, join Europe to Africa, and the dam itself would generate more electricity than the whole continent could use. He called it Atlantropa. He spent the rest of his life promoting it, books, films, exhibitions, convinced it would unite Europe and Africa into one peaceful superpower, Cheap oil, then nuclear power made the giant dam pointless, and the project quietly died with him in 1952. But look at what he was actually proposing. He was trying to recreate in a single lifetime the exact disaster the planet had already run by accident 5 million years before. He just didn't realize the planet had beaten him to it. Now, pull all the way back. Now imagine compressing all the time since that flood into just one day. For most of that day, human history has not even begun. No first cities, no pyramids, no Roman Empire, not even a written record. Then just before midnight, everything appears at once. Civilization, empires, science, and even this video. The sea in front of you feels permanent. It fills our maps, our memories, and our holiday photos, but to Earth, it is almost new. It isn't a fixed part of the planet. It's just the shape the planet is in right now, and shapes change. You don't have to look 5 million years into the past to watch a sea die. It's happening right now in more than one place. In Central Asia, the Aral Sea used to be one of the biggest lakes on Earth. Then in the 1960s, the rivers that fed it were drained off to water cotton fields, and within a single lifetime, most of the sea was gone. Fishing boats that once worked open water now sit rusting on dry salt kilometers from the nearest shore. Or take the Dead Sea between Israel and Jordan, so salty that almost nothing could live in it. It's dropping by about a meter every year because the river that feeds it has been tapped for farms and cities, and the ground around its edge is collapsing into sinkholes where the salt used to be. And these are small seas next to the Mediterranean. But the machine that's killing them is the same one that emptied the whole basin. Cut off the water coming in, and the sun does the rest. Because nothing that emptied this sea has stopped. Africa is still pushing north. The Mediterranean still loses more water to the sky than its rivers bring back. It's already saltier than the Atlantic next door, kept alive only by what pours in through that one narrow gate at Gibraltar. And that gate is slowly closing again. When it shuts, and given enough time it will, the models say the Mediterranean would only take about 2,000 years to dry out completely. What that next drying would actually look like. Which coastlines vanish, which cities end up stranded far from the water, is a whole video of its own. The desert we walked across today isn't only the sea's past, it's the sea's plan. So next time you stand on a Mediterranean beach or watch a ship cross that strait, you'll know what's beneath the water. 3 kilometers down, the old sea floor white with salt, waiting. The sea has done this before. The gate that ship is sailing through is already very slowly starting to close. So, if a whole sea disappearing feels impossible, the opposite is happening right now, just to the south. In East Africa, the ground is pulling apart. The continent is slowly splitting in two. Will this cause a flood like the one that refilled the Mediterranean? Find out in this video.